similar one would be given to you because they are all new. And the first part was just finding the solution, okay, integer solution of integer numbers, okay, so that's going to be the first one. Okay, that's a number one. You want to find all the numbers, positive integers, n in z or z positive if you like, such that n is going to be less than 700, and you want to find them so that they are going to be divisible by 2, 3, or 5. Okay, so that was the first one. You know that you have to use the addition law, so you have to prepare it. So the preparation is going to be that you're going to use it with the universal set, if you like. So this is the way you're going to explain it, solution. So we're going to suppose U to be, okay, there you are, suppose. You have to design the problem. U to be all these numbers between, okay, 1 up to the 700. That's going to be U. Then A is going to be all the numbers in U that are going to be multiple of 2. And the B is going to be all the numbers in U that are going to be a multiple of 3. And the C is going to be numbers in U that are going to be multiple of 5. Okay, so according to our formula, this is it. N of A union B union C is going to be N of A plus N of B plus N of C. Okay, minus the 2 by 2 one. A intersect B, A intersect C, and the B intersect C. And then you're going to add that total to it. So it's going to be plus N of A intersect B intersect C. Okay, that's going to be the formula. You have to explain how you got to get all the others. We talk about it. If you want to find all the numbers less than 700, it's going to be divisible by 2. It's going to be 700 divided by 2. If it's divisible, if it's done, otherwise we take its greatest integer part. So in this case, this is going to be 350. Then we go for the other one. And of B is going to be 700 divided by 3. Since it's not divisible, you're going to get a bracket and you get the integer. Okay, we get the integer part. Integer part for this number, I got it here. This is going to be 233. 233. Okay, the integer part for C. The C you want it to be divisible by 5. It is divisible by 5, so you don't need any bracket. So that gives 140. Okay, any question? So we go for the 2 by 2 one. A intersect B. This is going to be 700. Then you are going to divide it by 2 times 3. Okay, it's going to be like 350 over 3. And then it is not divisible. So you get the, sorry, I don't have the other format. This is going to be 116. So we have to use the bracket. We have to use a bracket, and it's going to be 116. And we just keep going. N of A intersect with C, which is going to be 700. Then you have to multiply the 2 times 5. That's easy. It's going to be 700. It is divisible, so it's going to be 70. Okay, and eventually we go with the N, B intersect C. That would be 700. 3 times 5. Okay, and this is going to be 140 over 3. Then this is not divisible. So we use the bracket to get this, okay, this number, which is going to be 46. 46 for, this is going to be the B intersect C. And then we identify the A intersect B intersect C, which is a 700. And that's going to be 2 times 3 times 5. Okay. So you simplify 2 times 5 would be 10. So that gives you 70 over 3. And you cannot, it's not divisible. So we use the bracket to get this one to be equal to 23. Okay, this is the way you are going to evaluate it for us. Any question? So go back, substitute, get the final answer. So N of union B union C is going to be 350, 233, and the 140 minus a 2 by 2, 160, 70, 46, and the plus 23. Okay, if you simplify it, this is going to be the final answer, 720, 723. These are the one that I got. I can post that. 232, and finally 23. So the final answer is 514. So 514 numbers are going to be less than 700 with these given properties. Okay, it's a very popular problem. One of them would be given to you on the find out. Just make sure to get these numbers right and design it nicely. You see, you have to connect the problems to the idea that we have. Okay, any question? So that was the first one. The second one is a straightforward one. And this is a kind of everything is given to you. You have to be careful because this is kind of complement of the addition formula that we have. Okay, so this is going to be the second one. The second one, we are in a class of 100 and total students. We get 191 students. Okay, and they are taking French, business, and music, and we have the information about all of them. So the way I'm going to design this one, I need to take, okay, again, you have to design it. You are going to suppose you would be all the students, okay? All the students, the total number of the students that taking those three, okay, that over all the students. Then we get F to be, the students taking, okay, this is going to be the elements if you like, or the students in U taking French. Okay, then we get the business. Again, students in U taking business. And you get the M to be students in U taking music. Okay, you have to connect the problems together. Okay, so what you want, just read it carefully. In this case, they ask you how many students are not taking any of those three cases, are not taking any of those three cases. So the idea is going to be, so the students that taking at least one of those, okay, at least one of those courses are going to be A union B union C. So if you consider the complement that give you what? That give you the students that are not going to be taking any of those. And this complement, you know that this complement is going to be, okay, it's going to be, we have the total one, which is going to be the U, and this is going to be minus, that's it, the complement of A union B union C. Okay, that's the way you design it. So it's going to be that formula that we did have for the, okay, for the complement version, if you like. Okay, and this is going to be just, this is just a set. Okay, that's a set notation. So the formula is going to be N of A union B union C. Complement is going to be N of U minus N of A union B union C. Okay, then just subtract, you just rewrite this formula and you have all the information is already given to you. So in this language, the notation that we have, We want to find those students that are not taking any of those courses. So this is going to be the total number of the students minus, that the single one. These are going to be the single one, then plus the 2 by 2 one, French business, French music, and the business and music. Okay, so negative, positive, so that gives us negative, the total number of taking the French business, the music and the business. Okay, this is going to be your formula. And for this problem, you already got all the information. You just substitute those numbers and you get the result right away. Okay, because the total number of the students is going to be 191. Okay, this is going to be 191 minus the students that are taking each single courses. Okay, you have the single one is, what's that? 18 are taking all together. Okay, 65 was taking French. It was given to you at the end. 76 taking, taking business, and 63 students were the one that taking. Okay, so the music, so the total one, the 2 by 2 one, the 2 by 2 one is given to you. This is going to be 10. Okay, that's going to be 10, 36, 10, 36, and 20. Okay, I think that's one. So this is going to be the total one, and those leftover that you are going to have is 10. Okay, you just put this together and you get the total number of that one. Okay, so let's just double check this number that I have. So 191, yeah, you get 51. The final answer is 51. Okay, so this is kind of a straightforward because you are not going to do anything extra for us. Okay, just reading it and getting it, make sure that you understand that you are going to use the complement version rather than the original one. Okay, any question?
I had a different formula for the complement. I did, after all the singles, I subtracted the doubles, and then I added the last part, which is all three of them. So my minus and plus is different. So I did minus.
You see, this is going to be
plus.
minus. Okay, this minus plus, minus plus.
I did
Oh,
minus,
yes. Oh,
minus, plus.
sorry. You are right. You see, negative, positive, negative, positive. That's it. You are right. Okay.
Okay.
You're going to be negative, positive. Yeah. I didn't see it, but you get 51. Yes. Yeah, you are right. Okay. Any question? So that is, be careful about the complements because you are going to use it twice. And we are going to use it again when we get to the next problem. And the next problem is just famous problem of permutations of, or arrangement, different arrangement of letters of alphabets. Okay. The one that they gave you was a couple of points that you have to consider. Remember, it's you want to see what's going to be the combination of all letters of alphabets. At best, you would like to exclude some format. The form that you want to exclude are going to be the net, okay, or the pattern, the words, and that's by T and dog or dog. Okay, so what you would like to do is you would like to get all the combination of the letter of alphabets that's not going to be containing any of this pattern. So again, this is a complement version of that theorem that we talk about it. So you have to arrange it accordingly. Again, the arrangement is important to explain it. Don't just write the numbers. So that's what he's talking about. Okay, U is going to be all Okay, all arrangement of alphabets, 26 letters of alphabet. So that would be our universal set. Then A is going to be, let's say, elements in U containing the first word, containing net. Your B is going to be, again, elements in your universal sets in U containing, okay, the second pattern, which is the by T1. And the C is going to be elements, okay, elements in U containing the duck. Okay, so that's it. That's a pattern. So now again, that same story that we talk about is a complement form. So this is it. So what we are going to be interested in, we are interested in N of A union B union C complement. Okay, this is the one. And we already talked about is going to be the number of the total minus the number are in the union of the sets. Now we can put them together and get the information that we are going to have. So it is going to be again minus the single one and A and B and C. And this is going to be plus the intersection A intersect B, A intersect C, and the B intersect C. Okay, negative, positive, and then the last one is going to be negative. Okay, negative, positive, the double, now the minus of the all together. Okay, any question? No.
If we didn't write like the suppose the U, A, B, C, would that be wrong? Because we didn't define the sets.
You mean this design?
Yeah.
Yeah, you have to tell us what formula do you use? So what's your mathematical design? So what do you want to write? You mean you just start with the numbers?
Well, if you just do like A equals net, B equals bite, C equals dog.
No, not equal. These are sets.
Okay.
You see, just I'll be patient. Just write something nice. At least write the first one. You see, write the first one, elements in U, then dash that. We accept that. Like the one, you see this one. Look at this.
Yeah,
at least write but the dash means you repeat it. I mean, it's mathematically, you have to tell us what the set is. Yes, it's nice because this is part of the design. At least write one of them. Because you have to show that this is a set, you see, because this formula is used for the sets. So that's why I just writing down. Okay, are you ready? Numbers, give us the numbers. You see the total, we talk about it, we know it, arrangement of the 26 letters would be 26 factorial minus, now N of A, remember, we are going to make this one first, okay, put it in the box. So in order to show it, form it, we need 3 letters. So 3 out of 26, that gives us 23, but this becomes a new letter. So 23, a new one, we call it alpha, you get 24. So that gives it 24 factorial. Any question? To form the net, you need 3 letters, 3 out of 26. That make it 23. 23 and this new one, because this is in the box now. 23 and the box, we get 24, so that gives it 24 factorial. Okay, we go with the next one. We need 4 letters to form this one, 4 out of 26, 22, 22 and the box, 23. Okay, this is 3 letters like the first one, 24. Any question? Now the one that you got to be careful is this 2 by 2 one. If they share a letter in between, you cannot have both of them at the same time. So look at this one. This is a net. So you already used E to form the net. So you cannot use it anymore. So you cannot have both of them together. So this means the number of the permutation of this part is 0. Okay, any question? Because you use only each letter once. So that would be plus. And now these two, there is nothing in between. So form it first, 3 and 3 to form it. That gives us 6. 6 out of 26 would be 20, but we have 2 boxes. 20 and 2, 22 factorial. Okay. So we did this one. The other one is this two. And the other, there is no common letters. So we have to form both of them. You need 4 letters to form this one and 3 here. 4 and 3 would be 7. 7 out of 26, that give us 19. 19 and 2 boxes, 21. 21 factorial. Any question? This last one is impossible because when you cannot form the first and the second, you cannot form all of them together. So that gives you 0. Okay, just be careful when you write it down. No explanation is needed. Just write in this format. Formula and the numbers. It can be a little bit simplified if you like. It's going to be, if there's going to be any like term, simplify it. I mean, 24 and 24 is 2 times 24 factorial. Okay, minus 23 factorial. And this is going to be, that's a 21 factorial. So that gives you 22 factorial, 22 factorial, and plus 21 factorial. Accept it as a final answer. Or you can use your calculator, to get the numbers. But that would be fine for us. Any question? So nicely design it and then give us the formula. This is very important because this is the complement of the addition, addition law or addition formula. So that's very important to write this addition formula and then the substitution, and you'll be fine. Okay, any question? So that's a number 3, very popular problem. To give you one of them. Nice, okay. Show us how you design a problem and just put them together. And that's, I just emphasize that, we make sure to write it down correctly, mathematically. And the next one is, we give you one problem regarding this multiplication rule directly. So this is number 4. We talk about the BMW and different design. So this is what we have. We have a BMW. And the BMW coming in different design, different model. Okay, 7 model and different color, different engines type. Okay, engine types and transmission. So this is going to be transmission. Okay, this is the way you just divide them together. A different format, you see BMW model, license plate model, different things that we're going to have. So the question is going to be, we want to know in general how many models are going to have. We know that we have 7 model of the BMW, 10 different colors. Okay, 3 different engine size and 2 transmission. When there is no restriction, it's just a product rule. So it's going to be the total number. It's going to be 7 times 10 times 3 times 2. Okay, 642, 420. So this is going to be the total number of the BMW that we can have. Okay, we're just applying the product rule to get the result. Any question? So no explanation is needed. This is tell us everything that you did. Okay, for the multiplication rule. The second part, they restricted. Okay. The second part, they restricted to the case that the restriction is going to be one of the available color is going to be black. Okay, so again, we get the format that we have. This is going to be the format of the BMW that we have over here. Okay, so you fix the color. So that was the model, the color, the engine, and the transmission. You fix the color, so the following you have only one choice because you would like to have a black one. Okay, everything else is going to be the same. So the same as the 7, okay, 7, 3, and 3 and 2. Okay, so in this case, what you have is going to be 7 times 1 times 3 and times okay times 2. So your choices is going to be very restricted. 6 times 7 is going to be 42. Okay, any question? So read it carefully. It's going to be easy problem, but you can easily miss it. But some of the numbers, just be careful. Read it and just we build up something similar, and we are going to ask you. Okay, to get the feeling of the multiplication rules that we developed. Okay, any question? So that was the number 4, and then we get the 5 and the number 5. Interesting one was number 5. And let's see, some of you just missed a couple of things about this one. And there is another version of this 5. Then let me see if I can give you a hint for that one too. Okay, we give you a formula for finding the number of integer solution of the given equation. In this case, the equation is x1, x2, x3, and x4, and this is going to be equal to the 32. If no restriction is given to you, you'll be interested in finding all the all the non-negative solution of these type of problems. And if it is no restriction was given, the formula that it's going to be C of n plus r minus 1 and r. And this is going to be the n is going to be the number of the unknown, and r is going to be this number over here. We're going to find it. And this is going to be so that would be the case if you're just looking for the non-negative integers. So for the non-negative integers means the case A that is given to you. This means if xi is going to be greater than or equal to the 0, or I is equal to the 1, 2, 3, and 4. Okay, each one of them can be greater than or equal to the 0. If this is going to be the case, just the formula, you just identify the n is going to be the total number of the variable, which is equal to the 4, and you add them together to get this r. R is equal to the 32. So just substitute in your formula. So C of n plus r minus 1 and r is going to be what? Is going to be C of 4 plus r 32 minus 1, and the r which is a 32. Just simplify it. So that gives C of 36, 35. Okay, it's going to be 35 and the 32. You simplify it, and they can use your calculator if you like, but you have to simplify that factorial part for us. So for this combination, it's going to be 35 factorial, and this is going to be 35 minus 32 factorial times it by 32 factorial. Okay, so this is going to be equal to, we have the 35 factorial on the top, 32 minus 35 minus 32, that gives you 3 factorial, and times it by 32 factorial. You break the top one, you stop it at you break it at 32 factorial to simplify it. So this is going to be, you can stop at 32 factorial, then you have to go up to the 35. So this is going to be 33, 34, 35. And the bottom one, 3 factorial here is going to be 6. 6 times 32 factorial. Now 32 factorial and 32 factorial will cancel out. Then you'll be able, to take care of the top. For example, you can simplify it by 3, that give you 2, that give you 11. And by 2, this is going to be 1, and that would be 17. So the final answer is going to be what's going to be 11 times 17 times 35. Okay, so this is going to be, I think, 6,000 something. This is going to be, yes, 6,545. 6,545. These are going to be the number of the solutions that you can have. Okay, any question? So this is going to be the case that we're going to have. So be careful. The expressions that's given to you important. This formula is going to be used, can be used only when xi is greater than or equal to the 0. If it's going to be anything else, then you have to modify your formula. So that's the first part. Any question? Now, the second part, they put some restriction for you, okay? These are some choices because this you are going to assign some numbers to the xi's, but sometimes you have to, you would like at least have one or two numbers in advance. So that is part B. In part B, they want to find the solution with this condition that the x1 must be at least 5, x2 again at least 5, okay, at least 5, then x3 is going to be greater than 7, and x4 is going to be greater than 7. You see, these are choices, the number of the choices that we're going to have. So what we are going to do, first thing is, this is x3 greater than 7, since we are looking for the integer, so we can change this one into greater than or equal to the 8. Okay, so this is going to be greater than or equal to the 5, greater than or equal to the 5, and this x3 would be greater than or equal to the next number, which is 8. And the x4 would be greater than or equal to the 8 again. Okay, now what we can do, we can, we can use a substitution, if you like, to change it to the, because if you just rewrite it, you see this is going to be greater than or equal to the 0, and that would be greater than or equal to the 0. And a shortcut, it can use a shortcut, even be accepted. And you see, this is the situation we're going to have. So now in the new format, you can call this one y1, y2, y3, and y4, because we are interested in the number of the solution, not the solution. Okay. So if you go back to that equation that's given to you, you see you have x1 plus x2 plus x3 plus x4 equal to the 32 that have. Okay. So if you call this one x1 minus 5 equal to the y1, so x1 would be y1 plus 5. It's going to be y1 plus 5, and this is going to be y2 plus 5, and that give you y3 plus 8, and that would be y4 plus 8, equal to the 32. So now you're going to be, y1, y2, y3, and y4, which is equal to the 32 minus those numbers, minus what? 5, 5, 8, and 8. So that give you y1, y2, y3, and y4 equal to the 32 minus, and that's a 10, 26. So that gives you 6. So you end up with solving this equation. 6 with the condition that all yi is greater than or equal to the 0 for I equal to the 1, 2, 3, and 4. You see, we changed the problem because we are interested in the number of the solutions, not the exact solutions. So the problem now is going to be the case that we have 4 variables again, n equal to the 4, and you want to add them to get the r equal to the 6. So it's going to be C of n plus r, 4 plus 6 minus 1, and r, which is 6. So that give a 10, 9. Okay, 9 and 6 is going to be the case. Now we are going to have to find it. It's going to be 9 factorial, and that's a 9 minus 6 factorial times a 6 factorial. So it's going to be 9 factorial on the top, and that's going to be 3 factorial, 6 factorial. So you can break it at 6, 6 factorial, then 7, 8, and 9. You know, you can list all of them and simplify, of course. But this, you know, if you like it. So that give you 3 factorial, 6 factorial. So these two would cancel out. And the 3 factorial would be 6. So the 7 times 8 times 9 over 6. And you simplify it by 3, that give you 2. And the by 2, that give you 4. Okay, 4 times 3 would be 12. 12 times 7 would be 84. So in this case, these are going to be the solutions that you're going to have. Okay, any question? So the algebra involved is interesting to get, you know, to get these problems that you are going to have. Okay, so be careful because this condition can be only held with this one. If you want something interesting for yourself, just think about it. What would happen if they give you one of these is going to be less than 3, for example, not bigger than. So what are we going to do with those type of problems? Okay, because you can only, this would give you the solution if it's going to be non-negative one. But if they switch one of them, then you have to kind of consider the complement of these type of arguments. And that would be that, you know, that would be the case. But this is interesting one. Okay, any question? So we just
So
give you one.
The
Yes.
original question for B says x1, comma x2 greater
Yes.
than or equal to 5. So is
Yes.
that supposed to be both of them, or was that
Yes.
supposed
Yeah.
to be just x2? Okay.
No. When they write x1, x2, they mean both of them. That's one. It would be better to write it in this format. Okay, on the final, I identify it for you because I know I saw that some of you now confused with that one. But basically, when it's in a sequence, you see x1, x2. Yeah, I will identify it precisely.
Okay, that'd be nice.
Yeah. That's what we want. Yeah, it should be. Okay, any question? So they are interesting problem. I told you, you will see, you know, somewhere, you are going to use it, this type of integers equations. That's the main thing. Sometimes we talk about those combination one. Most of the people use it for the binomial, expansion, etc. But this format is interesting. Okay, and that last one again, we wanted to see how you just, this arrangement of the letters again that we have. This is a problem from your book, in fact. That is number 6. And they are very popular, so we make up something similar and we'll give you. Okay, so we talk about the arrangement of this letter, this word, this algorithm. They can be, in different format. I just give you, we just discussed something which is not going to be, and does not contain any repeated letter because that would be different, but something just to get the feeling of those, permutations that we talk about it. Okay, so as we can see, we are going to have 9 letters here, yes, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 letters. And if you want to arrange it in different formats, you know that it's going to be just a permutation of 9 elements. You have 9 boxes and we have 9 letters, if you like, if you want to put them inside. So for example, since it's a 9, so different way, to think about it. The first, for the first choice, you have 9 choices because we have 9 letters. If you go to the next box, would be 8, 7, 6, okay, 6, 5, 4, 3, 2, and 1, which is the same as 9 factorial that we know it. Okay, so we have the formula. This is just for your information. That's how we're going to get it. So for the first part, they want to know how many arrangements of these letters in the list how different way you can list it. This is it. You start with 9 choices and just keep going. Okay, so that was the first part. The second part, they want to know how can you arrange 6 of these letters. Okay, you have the 9. That would be a permutation of a permutation of 9 elements, 6 at the time, if you like. But you can use the formula that we have for the second part. Okay, or you can form it yourself. So you have 9 letters. You want to just you want to arrange 6 of those. So what you can do is, again, for the first choice, you have 9 choices. Then you go with the 8, you go with the 7. Remember, you need only 6. So that gives you 1, 2, 3, 5, and 6. You see, 1, 2, 3, 4, 5, 6. So that give you the answer, because you are interested in these 6 letters that you have. This is going to be one format. I'm going to use the numbers in a minute, or the other one is simply, that this is going to be a permutation of 9 letters, 6 at the time, 6 at the time. So P of 9 and 6, and you know that P of 9 and 6 is what? Just to remind you, this is N and R. So this would be N factorial, N minus R factorial. So that gives you 9 factorial over 9 minus 6 factorial. So the top would be just 9 factorial, and the bottom one would be 3 factorial, which is the same as the other one, because you break it at the 3 factorial and you continue. You see 3 factorial, then you have to go with the 4, 5, 6, 7, 8, and 9. And this is 3 factorial. If you simplify it, it's the same thing. Okay, so you have 2 choices. Either one would be fine, and you can use it, and you can put these numbers together. What's the number? It's a big number. Let us see, part B. I made a mistake when I did it. Yeah, it's a 60,480. That's it. 60,480. In both cases, you will get the result. Okay, so give you different interpretation of the argument. If it's not going to be later something else, then you know how you handle it. Okay, any question? And the last part, they fix one of the, they fix at the beginning. They said how many 6 letters if the first letter must be A. Okay, so in this case, you fix the first one. So the first one is A. So that's it. You have one choice for A. Then you need 5 more. You see, this is going to be the A, then 5 more. 1, 2, 3, 4, 5. You see, that's going to be the one. So your choice for the first part is just 1. Now for the others, you did have 9 letters. So your first, you have 8 choices here. So we get the 8, 7, 6, 5. Okay, and that's 1, 2, 3, 4, 5, and 4. So that would be the number of the ways that you can have. Or you can say I fixed the first one, then for the other one, it's going to be permutation of permutation of 8 letters, 5 at the time, and that would be also correct. But these are just this is the way you just prove those formulas. So this is going to be the case. 6,000. I have 6,720 ways. Okay, so I see most of you did it right, just different formulas. So that gives you the idea. We give you a similar one on the final, then you are ready for it. That is the quiz. Any question?
Can you go back to number 3, please?
Number 3. That is number That's number
I just
3.
want to see the complement formula. It's the 26 letters of the English alphabet.
Oh yeah, that's 1. That's number 3. Because you get the complement of the union.
I think I just had some of my signs off.
Yeah, because you subtract the other one, so it's going to be, as you told us, it's going to be negative, positive, negative,
Negative.
positive. You missed it
And
again?
then, okay.
Negative, positive. You missed it again. Negative, positive. Why I missed it?
No, you have it right.
Right?
Yeah, you were right.
Negative.
Positive, and that's for
Negative.
those 3 that by
Oh, yes, I can't see it.
Those 3 are correct.
I'm
And
right.
the
I'm
last
right.
one.
I'm right. Yes.
Okay, good.
Okay. Just make sure you get it right and you write it down.